On December 25, 2021, the amazing James Webb Space Telescope was launched into space. But it still had a long road ahead. Due to its complicated unfolding process, it had reached its marker L2 and carefully got its mirrors aligned. And then, it sent this. This image was released almost a year ago on July 12, 2022. These images were just a hint of what was to come. And what came after it has been just blowing our minds. So let's celebrate JWST by looking at the most amazing discoveries by it so far. The JWST is special because in many ways, it's the most potent telescope we have. It can collect 6 times more light than Hubble, and it also covers a much wider spectrum. It's unlike anything else we've launched in space. From its vantage point above the Earth, it can offer a view into the deep parts of the universe. These areas are so distant and difficult to image that it's like looking through a time machine and viewing the earlier days of the universe. But the JWST is also versatile. It can help us look at exoplanets, and even planets in our own solar system. It can image stars, planets, and galaxies in unprecedented detail, and find things that other telescopes missed. The entire telescope was designed to answer some of the most burning questions in astronomy. Rowan Naidu was sitting at home and he found a galaxy. Yes, a galaxy just from his home. As his algorithm dug through early images from the James Webb Space Telescope, Naidu shot to attention. It had sifted out an object that, on closer inspection, was inexplicably massive and dated back to just 300 million years after the Big Bang, older than any galaxy ever seen before. At that moment, Rowan knew that it might be the most distant starlight we had ever seen. Days later, he published a paper on the candidate galaxy, which was named Galaxy 13, and the internet exploded. The extraordinary discovery of this galaxy, just weeks into Webb's full operations, was beyond astronomers' wildest dreams. Everyone was freaking out, said Charlotte Mason, an astrophysicist at the University of Copenhagen. We really weren't expecting this. As light from a very distant galaxy travels across the cosmic abyss, it is stretched by the expansion of the universe, a broadening of wavelengths known as redshift. Redshifts for early galaxies are so high that their emitted visible light has stretched into infrared by the time it arrives at our telescopes. The higher the redshift value, the more stretching the light has experienced, and thus the more distant its source galaxy will be. But now Galaxy 13 has been renamed to Galaxy 12, as it is not considered as redshifted as it was earlier, and is not the earliest galaxy ever seen. On number 2, we have the discovery of the oldest black hole ever discovered. Observations collected through the James Webb Space Telescope have revealed an active supermassive black hole 10 million times the mass of the Sun, one that is actively growing as it slurps up matter from the space around it. At just 570 million years after the Big Bang, this is the earliest growing supermassive black hole detected yet, although scientists are hoping it won't remain the record holder for long. The black hole was found inside one of the earliest galaxies ever detected, previously known as EGSY 8P7, though since renamed Sears 1019. Scientists were initially looking at Sears 1019 as part of their work investigating light produced by star formation in the very early universe. This light, called Lyman alpha emission, is thought to be generated by the ionization of neutral hydrogen by star formation activity. Sears 1019 and a handful of other super-early galaxies are excellent targets for this research, because they are relatively bright. Scientists still do not know how the black holes in those galaxies got to be so massive, that early on in the universe. Astronomers have found a number of exoplanets, but not with the JWST. In September 2022, James Webb released its first 4 images of exoplanets. 2 were shot with the MIRI camera and 2 were shot by NIRCam. So one of the things that's super exciting with JWST is the sheer diversity of exoplanets we can explore and characterize, says Elizabeth Matthews, a researcher at the Max Planck Institute for Astronomy. All of these planets orbit the star HIP 65426, located in the Centaurus constellation, with a distance of 385 light-years away from us. Researchers are particularly focused on planets that are farther away from their star. This way, the planet is less obscured by the star and the signal from the planet can be better detected. Some of the most exciting planets falling into this category are in the TRAPPIST-1 system. The star has a planetary system of 7 known exoplanets, and 4 of them are Earth-like planets that could potentially lie in the habitable zone, where temperatures are suitable for the existence of liquid water, and therefore, life. What's exciting about it is that a direct image of an exoplanet was never done before. And that's 2 months after JWST went online. Speaking of rare observations in the universe, JWST saw this. So what's this? Researchers on the spectrum of Webb found a brown dwarf, VHS 1256b, showing signatures of silicate clouds. While clouds are common in the solar system, these were found 72 light-years away. With the mass 19 times of Jupiter, the atmosphere is said to have contained sand particles flying around. But not only that, but also carbon dioxide. While sandstorms on brown dwarfs have been theorized, this is the first time they have been observed. Moving on, James Webb Space Telescope gave us a new perspective of one of the most popular space photos of all time. The Pillars of Creation. In 2014, the Hubble Space Telescope had taken this photo. To test Webb's capabilities, astronomers pointed it in its direction and we got this. The JWST variant is clearer, colorful, and full of details that Hubble could not see. This is the perfect way to see Webb's abilities to see through dust clouds using its infrared sensors. JWST used NIRCam to take this picture, hence it was able to see through all that dust. Even the murky background of Hubble looks like a sea of glitter in Webb's image. This just shows how far we have come with telescopes. Talking about perspectives, we have been given a totally new view of our own solar system. While JWST's main objective is to look at objects that are farther away than us, the telescope poses the ability to spot interesting things in our own solar system. In fact, a new light has been shed upon Uranus. In April 2023, we got footage of Uranus rings. While not as spectacular as Saturn's, we got a clearer look at Saturn's polar cap, which keeps appearing and disappearing, depending upon which season you observe it. Far from being just a pretty picture, the image can be useful for figuring out the inner workings of our solar neighborhood in greater detail, says project scientist Chris Evans. Astronomers hope to capture even better details of the planetary rings in our solar system, unlocking the secrets of their structure and composition, as well as the atmospheric composition of planets like Neptune and Uranus. Finally, we come to the most recent one. On the event of JWST's 1-year anniversary, the team released a photo of a star-forming area of a stellar nursery closest to our system, helping us understand the steps of how stars are formed, especially our Sun. As we are unable to see the 5,000 million-old star optically directly, its infrared sensors provide us with a very high resolution, enabling us to see very fine details regarding this process. There is approximately 1 new star being formed in the Milky Way every year, comments Tom Ray, Director of Cosmic Physics at the Dublin Institute for Advanced Studies, who has been working on the JWST project for over 20 years. Some of the most important theories on star formation are finally getting validated, says Ray. When it comes to looking for star-forming regions, supersonic jets are their telltale signs. These jets are an active phase that lasts for only around 100,000 years, and thanks to Webb, we're seeing them in unprecedented detail. At the time, the basic constituent ingredients were right in the center of the jets. So with the JWST, astronomers can explore the inner parts of young stars and see what materials are there, and even if there's any water present, which of course is very important. But this image here gives us the birth of 50 distant stars. Some of them are suns powering protoplanetary disks that could one day form a solar system, light years from our own. JWST isn't just amazing because of the science it offers, but also because of the stories it can tell. So, would you like to travel to the other side of the universe, or stick with us here, at the edge of the universe? Until we meet again.